Okay, so what we're going to be doing is continuing to do optimization problems. Unfortunately, though, we're not going to end up with nice quadratics. So we're definitely going to be using our calculator, right, to find high points or low points, because we only know how to find extrema if we have a parabola that opens up or down. So that's what we did in 4.4, why I started there. But here back in 3.6, going back in our book, we're still doing optimization. So we're still trying to find a max or a min of a situation based off of some sort of constraint, just like we did in the parabolic thing. So for example, in the parabolic things, we had perhaps a rectangle, and we were trying to maximize the area of that rectangle, but we were given a constraint, right? We were told that we only had so much fencing. Maybe we only had 1,000 yards of fencing. So my perimeter was the constraint. Well, we did that. Same thing with revenue, right? So for revenue, we have the function or the formula. My revenue is my units times my price. And then we were given some formula in terms of X and P that constrained the units and the price. And we ended up using that constraint to help us maximize that revenue. So that same rhythm is going to happen in this class, in this next part. But we're just going to be looking at different things, which we'll get into. But we're going to be basically trying to minimize distances, all right? And we're going to also be taking a look at areas of shapes. And these shapes are what we call inscribed in another shape, and that'll make more sense when I get to it. And then we're also going to be talking about problems where we take a wire and we cut it up into pieces, and for each piece we form a different shape, like a circle or a rectangle, right, or a triangle. Oops, I reverse those. So we're basically constrained, like in this one, the shapes are constrained by how much wire I have to begin with in the first place. The area of a shape, perhaps we're talking about a circle, and in that circle I'm building a rectangle. So we're going to try to maximize that rectangular shape, but we're constrained to some sort of circular. And then distances, the way we're going to talk about distances is I've got some graph, let's say it's a nice parabola, and I've got a point, and we're going to try to minimize, right, the distance between that point and any point along the edge. So we're basically constrained by that function, and we're going to try to figure out where's the, at what point along this on this graph is my distance the shortest. Of course, there's a lot of distances that are the longest because this goes on forever. But those are the kind of problems we're going to be doing. Again, there's going to be some sort of a distance formula or an area formula regarding the shapes, and then there's going to be a constraint. So we're constrained by a graph, we're constrained by some other graph, or we're constrained by how much wire that I have. And then each one of those cases, we're going to build a function, right? We'll just call it f of x right now. And then once we have that function, we can graph it. And so, maybe the graph looks this crazy, and we can see that there's a couple of high points, right? So we can, those are where my maximums would be. Or maybe we graph it and it, looks kind of like this. And so now we can see that there's definitely a low point. So there's my minimization. And so most of our graphs are not going to be quadratic now. So we'll definitely be using the graphing calculator to help us find those high points and low points as we do this. So there's your overview, and let's go ahead and get to work doing some problems.